Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P4 variant 2 February March 2018. Let's get started. A shop sells dress fabric for $2.97 per meter. A customer buys 9 meters of this fabric. Calculate the change he receives from $50. The change he receives would be equal to the amount he paid, which is $50, minus the amount he paid for the fabric, which is $2.97 times 9. This gives us $23.27. The selling price of $2.97 per meter is an increase of 8% on the cost price. Calculate the cost price. We know that the selling price, which is $2.97, is equal to 100 plus 8%, which is 108% of the cost price. When we make the cost price the subject, this is what we have. When we type this into the calculator, we get $2.75. A dressmaker charges $35 or 2,300 rupees to make a dress. Calculate the difference in price when the exchange rate is 1 rupee equals $0.0153. Give your answer in rupees. We need to give our answer in rupees. So we need to find the equivalent of $35 in rupees, which is what we are calling X, using the given exchange rate. When we cross multiply and make X the subject, this is what we get, which is equal to 2,287.58 rupees. So now the difference in price would be 2,300 rupees minus 2,287.58 rupees, which is equal to 12.42 rupees. The dressmaker measures a length of fabric as 600 meters, correct to the nearest 5 meters. He cuts this into dress lengths of 9 meters, correct to the nearest meter. Calculate the largest number of complete dress lengths he could cut. Since we are correcting the fabric length to the nearest 5 meters, we have 600 meters. Then we bring in plus and minus 5 meters and divide 5 meters by 2. And for the dress length, which we are correcting to the nearest meter, we have 9 meters. Then we bring in plus and minus 1 meter. Then we divide 1 meter by 2. We get the largest or upper bound of the number of complete dresses he can cut by dividing the upper bound of the fabric length by the lower bound of the dress length. To get the upper bound of the fabric length, we ignore the minus, so we have 600 plus 5 over 2 meters. And for the lower bound of the dress length, we ignore the plus, so we have 9 minus 1 over 2 meters. When we type this into the calculator, this is what we get. This means the complete number of dress lengths he can cut is 70. The vertices of a square ABCD lie on the circumference of a circle radius 8 centimeters. Calculate the area of the square. Here is the formula for the area of the square. One of the sides of the square is AD. To get AD, we apply the Pythagoras theorem. So we have AD squared equals 8 squared plus 8 squared. When we make AD the subject, this is what we get, which is equal to 8 root 2 centimeters. So now the area is 8 root 2 centimeters all squared, which is equal to 128 centimeters squared. Calculate the area of the shaded segments. To get the area of the shaded segments, we subtract the area of the square from the area of the circle and divide by 4. The area of the circle is pi r squared, where the radius r of the circle is 8 centimeters. We found the area of the square in the previous question to be 128 centimeters squared. When we type this into the calculator, we get 18.3 centimeters squared, rounded to 3 significant figures. Calculate the perimeter of the shaded segment. The perimeter of the shaded segment is equal to side AD plus the length of arc AD. We found the length of side AD to be 8√2 centimeters. We can get the length of arc AD using theta over 360 degrees times 2 pi r, where theta is 90 degrees and the radius r is 8 centimeters. When we type this into the calculator, we get 23.9 centimeters, rounded to 3 significant figures. The table shows some values for y equals 2x plus 1 over x minus 3. For x is greater than and equal to 0.125 and less than and equal to 3. Complete the table. When we plug in x equals 0.5 into the equation, we get y equals 0. For x equals 0.75, we get y equals negative 0.17, and for x equals 2.5, we get y equals 2.4. On the grid, draw the graph of y equals 2x plus 1 over x minus 3 for x is greater than and equal to 0.125 and less than and equal to 3. So on the grid, we plot all the points in the table and connect the points with a smooth line. Use your graph to solve. 2x plus 1 over x minus 3 is greater than and equal to 2. We know the function of the graph is y equals 2x plus 1 over x minus 3. So we are asked to find the x points of the graph in the region where the graph lies above the line y equals 2. On the grid, we draw the line y equals 2 and mark its intersection points with the graph, which have x coordinates 0.225 and 2.275. We see that there are two regions of the graph that is above y equals 2. For the first region, the x-coordinates are to the left of 0.225. This can be described as x is less than and equal to 0.225. And for the second region, the x-coordinates are to the right of 2.275. This can be described as x is greater than and equal to 2.275. The equation 1 over x equals 7 minus 3x can be solved using your graph in parts B and the straight line. Write down the equation of this straight line. We know the equation of the graph is y equals 2x plus 1 over x minus 3. We've only been given 1 over x on the left-hand side, so we bring in 2x minus 3. If we have added 2x minus 3 to the left-hand side, we also need to add 2x minus 3 to the right-hand side to balance the equation. When we group like terms on the right-hand side, 7 minus 3 is 4. Minus 3x plus 2x is minus x. This means the equation of the straight line is y equals 4 minus x. Draw this straight line and solve the equation. 1 over x equals 7 minus 3x. In the previous question, we expressed the given equation as this. This means the solution to the given equation is the x-coordinates of the intersection points between the graph of y equals 2x plus 1 over x minus 3 and the line y equals 4 minus x. To draw the line y equals 4 minus x, we need a minimum of 2 points on the line. When we plug in x equals 0 into the equation of the line, we get y equals 4. And when we plug in x equals 3, we get y equals 1. So on the grid, we plot the points 0, 4 and 3, 1 and connect the points with a straight line. The line intersects the graph at 2 points with x coordinates 0.15 and 2.175. Make t the subject of the formula s equals k minus t squared. When we make t squared the subject, we have t squared equals k minus s. To make t the subject, we take square root of both sides. This gives us t equals plus and minus square root of k minus s. Factorize x squared minus 25. 25 can be written as 5 squared. By applying the factorization for the difference of two squares, this can be written as x plus 5 times x minus 5. Simplify x squared minus 25 over x squared minus 2x minus 35. From the previous question, we found the factorized form of x squared minus 25 to be x plus 5 times x minus 5. To factorize the denominator, we write minus 2x as 5x minus 7x. For the first two terms, when we factor out x, we are left with x plus 5. And for the final two terms, when we factor out negative 7, we have x plus 5. This can be rewritten as x plus 5 times x minus 7. X plus 5 cancels out, so we are left with x minus 5 over x minus 7. Write as a single fraction in its simplest form. To write this as a single fraction, we cross multiply, giving us x minus 8 times x plus 1 plus 3x times x, which is 3x squared. Then we divide by the LCM of the fractions, which we get by multiplying the denominators. When we expand x minus 8 times x plus 1, we get x squared plus x minus 8x minus 8. When we group like terms, x squared plus 3x squared is 4x squared. X minus 8x is minus 7x. So we have 4x squared minus 7x minus 8 over x times x plus 1. Find the integer values of n that satisfy the inequality. 6n is greater than 18 minus 2n and less than and equal to 30 plus n. First, we need to split the inequality into two. So we have 6n is greater than 18 minus 2n and 6n is less than and equal to 30 plus n. Let's start simplifying the first part. When we add 2n to both sides, we get 8n is greater than 18. And when we divide both sides by 8, we have n is greater than 2.25. Let's simplify the second part. When we subtract n from both sides, we get 5n is less than and equal to 30. And when we divide both sides by 5, we have n is less than and equal to 6. When we bring these two together, we see that n is greater than 2.25 and less than and equal to 6. The integer values of n in this range are 3, 4, 5, and 6. The diagram shows a solid prism with length 15.2 centimeters. The cross-section of this prism is a regular hexagon with side 7 centimeters. Calculate the volume of the prism. Here is the formula for the volume of a prism. The length L of the prism is 15.2 centimeters. In this case, the cross-section of the prism is a regular hexagon, so we need to find the area of the hexagon. The hexagon can be split into 6 equal triangles, so we need to find the area of one triangle using the formula half base times height and multiply by 6. The base B of each triangle is 7 centimeters. So now we need to find the height. First, we find the interior angle of the hexagon using this formula for regular polygons. We have a hexagon, so n is 6. This gives us 120 degrees. If the interior angle of the hexagon is 120 degrees, then it means each of these two angles is 60 degrees. If we divide the base of the triangle by 2, we get the base of the right angle triangle to be 3.5 centimeters. So now we can get h using SOHCAHTOA. This gives us tan 60 equals h over 3.5 centimeters. When we make h the subject, we get h equals 3.5 tan 60 centimeters. So for the cross-sectional area of the prism, we get 73.5 tan 60 centimeters squared. When we type this into the calculator, we get 1940 centimeters cubed, rounded to 3 significant figures. Calculate the total surface area of the prism. The total surface area of the prism is equal to the area of the two hexagons, which is 2 times 73.5 times 60 centimeters squared, plus the area of the 6 rectangles, which is 6 times 15.2 times 7 centimeters squared. When we type this into the calculator, we get 893 centimeters squared, rounded to 3 significant figures. Another solid metal prism with volume 500 centimeters cubed is melted and made into 6 identical spheres. Calculate the radius of each sphere. If the prism is melted to make 6 identical spheres, then it means the volume of the prism is equal to the volume of the 6 spheres. We've been given the volume of the prism to be 500 centimeters cubed. We've also been given the formula for the volume of a sphere to be 4 over 3 pi r cubed. 6 times 4 over 3 is 8. When we divide both sides by 8 pi, this is what we get. And when we take cube root of both sides, this is what we have. When we type this into the calculator, we get 2.71 centimeters, rounded to 3 significant figures. Klaus buys X silver balloons and Y gold balloons for a party. Write down 4 inequalities in terms of X and or Y to show this information. We are told the number of gold balloons he buys, which is Y, is greater than the number of silver balloons, which is X. So we have Y is greater than X. We are told he buys at least 15 silver balloons. This means the number of silver balloons he buys, which is X, is greater than or equal to 15. We are also told he buys less than 50 gold balloons. So Y is less than 50. Then finally, we are told he buys a total of no more than 70 balloons. This means X plus Y is less than or equal to 70. On the grid, show the information from part A by drawing 4 straight lines and shading the unwanted regions. Before we can shade the unwanted regions, we need to draw the boundaries or the lines for each of the inequalities. So for each of the 4 inequalities, we draw the lines y equals x, x equals 15, y equals 50, and x plus y equals 70. Note that we draw the lines y equals x and y equals 50 as broken lines because they do not have an equal sign attached to their inequalities. For the first inequality, y is greater than x, the region above the line y equals x is wanted, and so we shade the region below the line. For x is greater than and equal to 15, the region above the line x equals 15 is wanted, and so we shade the region below the line or to the left of the line. For y is less than 50, the region below the line is wanted, and so we shade the region above the line. For x plus y is less than and equal to 70, the region below the line is wanted, and so we shade the region above the line. Silver balloons cost $2 and gold balloons cost $3. Calculate the most that Klaus could spend. We can find this by picking a point in the wanted region that gives us the most he could spend. This point cannot be 2050 because it falls on a broken line. When we move down one step further, we pick the point 2149. So $2 times 21 plus $3 times 49 gives us $189. The frequency table shows information about the time and minutes that each of 160 people spend in a library. Find the probability that one of these people, chosen at random, spends more than 100 minutes in the library. This probability is equal to the number of people who spend more than 100 minutes in the library, which is 9, divided by the total number of people, which is 160. Calculate an estimate of the mean time spent in the library. The mean is equal to the total time spent by all the people in the library divided by the total number of people. Before getting the total time spent by all the people in the library, we need to get an average time for each of the time intervals. So for the first interval, the average time is 0 plus 10 divided by 2, which is 5. Then we have 10 plus 40 divided by 2, which is 25. 40 plus 60 divided by 2, which is 50. 60 plus 90 divided by 2, which is 75. 90 plus 100 divided by 2, which is 95. 100 plus 120 divided by 2, which is 110. So we have 5 times 3 plus 25 times 39 plus 50 times 43 plus 75 times 55 plus 110 times 9 minutes divided by the number of people, which is 160. When we type this into the calculator, we get 58.125 minutes. Complete the cumulative frequency table below. For m is less than or equal to 60, the cumulative frequency is 3 plus 39, which is 42, plus 43, which is 85. For m is less than or equal to 90, the cumulative frequency is 85 plus 55, which is 140. For m is less than or equal to 100, the cumulative frequency is 140 plus 11, which is 151. For m is less than or equal to 120, the cumulative frequency is 151 plus 9, which is 160. On the grid opposite, draw the cumulative frequency diagram. On the grid, we plot all the points in the cumulative frequency table and connect the points with a smooth line starting from the origin. Use your cumulative frequency diagram to find the median. To get the median, we map half of 160, which is 80, on the diagram. This gives us the median to be 58 minutes. Find the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. To get the upper quartile, we map 3/4 of 160, which is 120, on the diagram. This gives us 78 minutes. To get the lower quartile, we map 1/4 of 160, which is 40, on the diagram. This gives us 39 minutes. 78 minus 39 gives us 39. Find the 90th percentile. To get the 90th percentile, we map 90% of 160, which is 144, on the diagram. This gives us 94 minutes. Find the number of people who spend more than 30 minutes in the library. On the diagram, when we map 30 minutes from the horizontal axis to the cumulative frequency graph, we get 26, which represents the number of people who spent 30 minutes or less at the library. So to get the number of people who spent more than 30 minutes, we subtract 26 from the total number of people, which is 160. 160 minus 26 gives us 134. The diagram shows two pots, L and P, and a buoy, M. The bearing of L from P is 201 degrees and LP is 248 kilometers. The bearing of M from P is 127 degrees. Angle PML is 42 degrees. Use the sine rule to calculate LM. We've been given the bearing of L from P to be 201 degrees, and we've also been given the bearing of M from P to be 127 degrees. So to get angle LPM, we subtract 127 degrees from 201 degrees, which gives us 74 degrees. Now that we have this angle, we can use the sine rule to get LM. When we apply the sine rule to the triangle, this is what we get. When we make LM the subject, this is what we have. When we type this into the calculator, we get 356 kilometers, rounded to 3 significant figures. A ship sails directly from L to P. Calculate the shortest distance from M to LP. The shortest distance from M to LP is the same as the perpendicular distance from M to LP, which is what we are calling y. To get y, we apply SOHCAHTOA. This gives us sine 64 equals y divided by 356 kilometers. When we make y the subject, this is what we get. When we type this into the calculator, we get 320 kilometers, rounded to 3 significant figures. The ship leaves L at 20:45 and travels at a speed of 40 kilometers per hour. Calculate the time the next day that the ship arrives at P. First, we need to find the time it took for the ship to travel from L to P, which we can get using this formula. The distance d between L and P is 248 kilometers, and we've been given the speed of the journey to be 40 kilometers per hour. This gives us 6.2 hours. To convert 0.2 hours to minutes, we multiply 0.2 by 60. 0.2 times 60 is 12. Now we know the time duration for the journey was 6 hours 12 minutes. So to get the time the ship arrives at P, we add 6 hours 12 minutes to its departure time, which was 20:45. Under the minutes column, 45 plus 12 is 57. Under the hour column, 20 plus 6 is 26. 24 hours is 1 day. So we add 1 to the day column and leave the remaining 2 hours under the hour column. Under the day column, 1 plus 0 is 1. Since we have 1 under the day column, it shows that the ship arrives the next day at 2:57. Find the magnitude of the vector -17. In this case, we apply the magnitude of a vector formula to the given vector, and this is what we get, which is equal to 7.07 rounded to 3 significant figures. The determinant of the matrix 6, 5, 2m is 24. Find the value of m. To get the determinant of the given matrix, we subtract the product of the minor diagonal, which is 10m, from the product of the major diagonal, which is 6m. This is equal to 24. 6m minus 10m is minus 4m. When we divide both sides by -4, we get m equals -6. Work out the following. N is a 1 by 2 matrix and M is a 2 by 1 matrix. So the resulting matrix would be a 1 by 1 matrix. To get the number in this position, we multiply the elements in row 1 of the first matrix with the elements in column 1 of the second matrix. So 1 times -4 plus 7 times 2 gives us 10. L is a 2 by 2 matrix and M is a 2 by 1 matrix. So the resultant vector from the multiplication would be a 2 by 1 matrix. To get the number in this position, we multiply the elements in row 1 of the first matrix with the elements in column 1 of the second matrix. So 2 times -4 plus 5 times 2 gives us 2. To get the number in this position, we multiply the elements in row 2 of the first matrix with the elements in column 1 of the second matrix. So 3 times -4 plus 9 times 2 gives us 6. L is a 2 by 2 matrix. When we multiply two 2 by 2 matrices, the resulting matrix would also be 2 by 2. To get the number in this position, we multiply the elements in row 1 of the first matrix with the elements in column 1 of the second matrix. So 2 times 2 plus 5 times 3 gives us 19. To get the number in this position, we multiply the elements in row 2 of the first matrix with the elements in column 1 of the second matrix. So 3 times 2 plus 9 times 3 gives us 33. To get the number in this position, we multiply the elements in row 1 of the first matrix with the elements in column 2 of the second matrix. So 2 times 5 plus 5 times 9 gives us 55. To get the number in this position, we multiply the elements in row 2 of the first matrix with the elements in column 2 of the second matrix. So 3 times 5 plus 9 times 9 gives us 96. The inverse of matrix L is equal to 1 over the determinant of matrix L, which we get by subtracting the product of the minor diagonal of the matrix, which is 5 times 3, from the product of the major diagonal, which is 2 times 9. Then we multiply by this matrix, which we get by swapping the elements in the major diagonal of the matrix and negating the elements in the minor diagonal. For the determinant, 2 times 9 minus 5 times 3 is 3. So we have 1 over 3 times 9 negative 3, negative 5, 2. Calculate the length of AB. To get the length of AB, we apply the distance or length formula, and this is what we get. When we type this into the calculator, we get 10.8 rounded to 3 significant figures. The point P has coordinates 10, 12, and the point Q has coordinates 2, negative 4. Find the coordinates of the midpoint of the line PQ. To get the midpoint of PQ, we apply the midpoint formula, and this is what we get. 10 plus 2 divided by 2 is 6. 12 plus negative 4 divided by 2 is 4, so we have 6, 4. Find the gradient of the line PQ. To get the gradient of PQ, we apply the gradient formula, and this is what we get, which is equal to 2. Find the equation of a line perpendicular to PQ that passes through the point 2, 3. All we need to do is find the values of M and C for the perpendicular line and plug them into the equation y equals mx plus c. The product of the gradient of the perpendicular line M and the gradient of line PQ, which we found to be 2, must be equal to negative 1. When we divide both sides by 2, we get M to be negative 1 over 2. To get C, we plug in the value of M and the coordinates on the perpendicular line into y equals mx plus c. This gives us 3 equals negative 1 over 2 times 2 plus c. Negative 1 over 2 times 2 is negative 1. When we add 1 to both sides, we get c equals 4. So we have y equals negative 1 over 2x plus 4. The table shows the first 5 terms of sequences A, B, and C. Complete the table. When we look at the terms in sequence A, we see that they are perfect squares. So the sixth term would be 5 squared, which is 25. For sequence B, the terms have a constant difference of 1 between them. So to get the sixth term, we add 1 to 8, which gives us 9. To get each term in sequence C, we subtract the corresponding term in sequence B from the term in sequence A. So for the sixth term, 25 minus 9 gives us 16. Find an expression for the nth term of sequence A. We can use the quadratic sequence formula to get the nth term, or we can skip that because the pattern is straightforward. The nth term is n minus 1 squared. Find an expression for the nth term of sequence B. Since the terms in sequence B have a constant difference between them, we can use this formula to get the nth term. A1, which is the first term, is 4. D, which is the common difference, is 1. N minus 1 times 1 is n minus 1. When we group like terms, 4 minus 1 is 3, so we have n plus 3. Find the value of n when the nth term of sequence A is 576. To get this, we equate n minus 1 squared to 576. When we take the positive square root of both sides, this is what we get. Square root of 576 is 24. When we add 1 to both sides, we get n equals 25. Find an expression for the nth term of sequence C. Give your answer in its simplest form. To get the nth term for sequence C, we subtract the nth term for sequence B, which is n plus 3, from the nth term for sequence A, which is n minus 1 squared. When we expand n minus 1 squared, we get n squared minus 2n plus 1. When we expand the other brackets, negative 1 times n is negative n. Negative 1 times 3 is negative 3. When we group like terms, minus 2n minus n is minus 3n. 1 minus 3 is minus 2, so we have n squared minus 3n minus 2. Find the value of the 30th term of sequence C. To get this, we plug in n equals 30 into the nth term formula we got for sequence C. So we have 30 squared minus 3 times 30 minus 2, which is equal to 808. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.